Here we have another example of cos to the m sine to the n x, where 1 is even, 1 is odd again. Now, it's cos squared sine cubed x dx, and we are asked to evaluate it. Well, we said when you have 1 being odd, 1 being even, you are going to use the trig identity that says sine squared x plus cos squared x is equal to 1. This knowledge is what you need to have, okay? You need to have this knowledge. All right, now, how are we going to do it? We said anything with the odd power is what you're going to split. And you split it too, remember? The highest even power that you have, and then you remain with only 1. So here's how it's going to be like 0 to pi over 2 of cos squared x sine cubed x with respect to x, the integral. Right? And what is it going to look like? Well, you're just going to split that. How are you going to split? You'd say it's from 0 to pi over 2 of cos squared x. The highest even power before 3 is 2, so it'll be sine squared x. Then you remain with only 1 sine x. There, you put it again. And this is with respect to x. Now you're going to replace sine squared x, okay? You're going to replace sine squared x with what it is. Well, sine squared x from here, sine squared plus cos squared is 1. So if I want to have sine squared, I take cos squared to the other side. That becomes 1 minus cos squared x. So that means it's the integral from 0 to pi over 2 of cos squared x multiplying 1 minus cos squared x multiplying sine x, all with respect to x. Wow, when it's like this, you're doing it. Okay, so here it's integral from 0 to pi over 2 of, what you're going to do is just expand, right? Of course, yeah, you're just going to expand this. And what's going to happen is I'm going to multiply everything by sine squared, or by cos squared, and I'm going to have cos squared x times 1 as cos squared x. Then cos squared x times cos squared x is cos to the 4 of x, but the negative sign is still there. And all this is multiplying sine x, all of it, okay? And it's with respect to x. So now I have 0 to pi over 2 of sine x by cos squared x, okay? Minus sine x by cos to the 4x. And all this is with respect to x. Right, so if we can rewrite it, I'm going to have the integral from 0 to pi over 2 of, I can rewrite it like this, cos squared x multiplying sine x, and this is with respect to x, minus the integral of, I'll say cos to the 4x multiplying sine x, and it's also with respect to x. Now we said if you have a power sitting next to a guy without a power from another thing. So I have cos squared now, and he's sitting next to sine, and I'm integrating. We said what is just going to happen is you increase the power of cos by 1. It becomes cos cubed x. Then you divide by that new power, divided by 3. Okay? And this is from 0 to pi over 2, obviously. But since the other one is the very same thing, we'll say minus. Here, we increase the power again, cos to the 5x. Then we divide by that new power, divided by 5. And here, because it's a definite integral with bounds, 0 to pi over 2, then we will not have to, we don't have to put the constant of integration. Now, we start with pi over 2 in there. So it's cos cubed pi over 2. And if you want to put this is how you can write it. When you're evaluating it, this is how you know it looks like. Cos cubed is cos x cubed. So it'll be cos pi over 2 all cubed. And that's divided by 3. Then minus cos pi over 2. And this is all raised to the power of 5 divided by 5. And this is minus. Now we have cos 0 cubed over 3 minus cos 0, okay, and this is to the power of 5, and it's over 5. Well, if you put cos pi over 2, right? You say cos pi over 2, it's like saying cos 90, right? And you should get the 0. Okay, you must definitely get a 0 because at 90 it's 0. So here it's 0 to the power of 3, which is still 0. So this is 0 minus cos pi over 2 is 0 again. So it's 0 minus 0 minus, because if the numerator is 0, everything will go to 0, okay? So 0 divided by 3 is still 0. 0 divided by 5 is still 0. Then this is minus what? Cos 0 is 1. 1 cubed is still 1. So it's 1 over 3 minus, cos 0 is 1 again. To the power of 5 is still 1. So it becomes 1 over 5, right? And if I have this negative affecting both, then the 1 over 5 will then become positive, and the 1 over 3 will become negative. So it's 1 over 5 minus 1 over 3. And if you put over the same denominator, which is 15, you multiply 5 by 3, you get 15. 5 into 15 is 3. By this 1 on top is 3. So 3 minus this minus 3 into 15 is 5 times 1 is 5. So you get negative 2 over 15 as your answer. And that's how you solve it. That's how you solve it, right? Okay, good. So negative 2 over 15 can also be written as negative 0.133. All right. Anyway, thank you. We'll see another example in the video to come.